Good afternoon, everyone. I will be telling you a little bit about instructions. Just as a background, our solution, Proceedix, is a cloud platform to manage the content of work instructions and procedures, which are then executed either by mobile technology or by wearable devices like Google Glass or smartwatches in combination with a mobile device. My background is in manufacturing and logistics for about 20 years, and that's the perspective that I will be giving. And maybe as the last presenter today, I might end with a few pragmatic notes. Let's put it this way. When we are discussing instructions and what you need for instructions, it all depends. And it's hard to make a general statement, so I put this formula a little bit inspired on a Lean Six Sigma approach. What you need in terms of instructions is a function of influential factors. And those influential factors is the industry, for example. In some places, you cannot touch a device, a Google Glass or any other device on your nose because your hands are dirty. In other places, you can't touch it because you're in a lab and you might contaminate stuff. So it's a totally different game bringing instructions to somebody in such an environment. But then also the operator, the tasks he's performing, the profile he has. Some people are masters in engineering and other people barely can read. And you need to bring instructions to these people. The process is an influential factor. So all of these elements influence what you need in terms as instruction support. And what is also important, when I'm talking instruction support, I'm not talking machine-to-machine communication. I'm talking an individual that is involved in the process and possibly interfering, or most of the time interfering with machines. But it's the human interaction that is key, and it's that human that you want to guide with instructions. And then the challenges of instructions, and there I agree also with what has been mentioned earlier today, is that the instructions, the challenges that we are facing is a function of the needs, and in some cases simple needs, in some cases quite complex needs, and the technology. And I would dare to say that technology constraints are the source of most of the challenges we face in instruction support today. If we take an example of, and I'll take that example along the presentation, if we take an example of a technician, by the way, a technician is not to be compared with somebody from quality control or with an operator in a process industry, is not to be compared with an operator in an assembly operations. But let's take this technician. He basically does three things in a day. He does repairs and maintenance. These things are typically managed in SAP plant maintenance, in Maximo. It's shutdown type of stuff, revisions. You need spare parts. You need sometimes contractors helping you out. You need to organize all that. And it's most of the time managed by a computer maintenance system. But then next to that, the guy is doing checks twice a day, twice a week. He's walking around and he does a temperature check here, a pressure check on a compressor every day or twice a day. And he's not managing that in SAP, far too complex. He just walks around with his logbook, writes down or print on a printed paper, does his tour and fills out the form every day. And then there is a third level of activity he has. Once in a while they call him, and they call him from the manufacturing floor because they're doing a changeover from, let's say, a 50 centiliter bottle to a 25 centiliter bottle. There need to be 30 tasks performed, 26 by the operators of the machine, flushing the pipes, to give one example. But then for certain tasks like changing the robots, they need to call in the technician. And there again, he drops in 15 minutes, 1 hour, not managed again in SAP, just helping out his colleagues on the operational, on the work floor and making sure that everything happens the way it should be. That's the life of a technician. And I like the statement earlier today again of somebody that said, if you want to talk how we gonna help people, we should walk with these people and really understand what they're doing. And this is exactly what I try to highlight here. Now, okay, we know what he does. Next thing is, how are we going to make sure he does what he has to do and he does it right? There we have, if you talk instructions, it's a broad scala of things. You have standard operating procedures. It's the text blah, blah, blah that tells you what needs to be done, who needs to be there, why it needs to be done, and it certifies that you got an ISO certificate. You use these documents to introduce new people, but I would say basically you're supposed to know what is in these documents before you walk onto a manufacturing floor. Then the second, most of it is, by the way, in Word. I would dare to say 95% is Word-based in companies. And then the second level of instructions is work instructions or inspection instructions. They tell you something different. They tell you a specific thing, how that task, activity exactly needs to be done. You open this, you clean it out, you replace a filter, and most of the time we encounter Excel sheets where there is step-by-step blocks with pictures, and they tell them how it should be done. And then the third, because whatever we say here today on augmented reality and on very advanced technology that has tremendous potential, but reality is manufacturing floors and warehouses are flooded with paper today. And the third stream of paper that we still see everywhere is log sheets. What are log sheets? Okay, you write me down every hour the temperature, the pressure, because I want to make sure you paid attention. You're awake. You're keeping an eye open. And so you write it down. Then we are sure we're monitoring the game. So I would say part of instructions are stuff to read, to know, before you go into the action. And the other part is, while you're doing it, please register, please log, or have another look that you do it the right way, first time right. And then the work order, that's a different ballgame. Work order is simply telling them what needs to happen right now, be it a repair or be it a production. Now, devices. What is the right platform to use? If you read stuff, don't use a Google Glass, don't use all of these nice, smart eyewear that you can see here. You have to sit down to read. Look at your terminal, look at a tablet, that's fine. That's stuff to read. But when you're in the action, not reading needs to be done before you enter the floor, but when you're entering the floor and you need to log some things, or you need to follow a specific step-by-step sequence, and we want to make sure that even you're supposed to know it, you go step by step, then you need to do two things at the same time. You need to do your work, and you need to capture information. It means you need to, what we call snack, like fast food consumption. You need to snack information in a blink of an eye, and you need to be able to log. And there is a big advantage to have your hands free. So here, okay, a tablet and a phone, but then you have to put them down and sometimes put them away. A glass is easier. A watch is on your wrist and is also easy. So snack information and log information is the essence of where Google Glass, where the OptimVents and all the devices, the Moverios and so come in. So the case in business, there are plenty of cases. There are plenty of cases, it's always the same. It's helping the deskless worker, mobile and hands-free, paperless, make sure he did it, prove he did it, so compliancy, first time right, and then don't do twice an input, do it once, so make sure it's integrated. And that can be done in quality control, it can be done in maintenance, asset inspection, on the manufacturing floor, field services, logistics, everywhere. The question is now, how are we going to empower that deskless operator? The first thing, I have one here, for those that are not familiar with it, this is a beacon. Most known maybe, if you know it, Estimate is one brand that is quite popular. And what is a beacon? The hype was more in marketing. It's a device, you stick it here, it sends a signal. It doesn't do anything than sending a signal every X seconds or milliseconds. It's me, it's me, it's me, it's unique. And when you move by with a phone or another device that has an app that is designed to listen to this one, not to another one, to this one, then suddenly that device wakens up, goes to a server and says, I just heard this one shouting, it's me, it's me. And then the server says, okay, now I've got news for you, tell him to stop, or tell him to do this. So this, I would say, primarily a marketing device, because for promotions, sticking it on the shelf and giving you a promotion on a pizza. No, it's interesting when you stick it on a machine and the technician walks by, he doesn't need to tell you he's at the machine. This thing is telling you he entered the parameter of the machine. And so what is the primary function, or the primary functions in industry for this device? It is twofold. First, indoor location, because GPS in an iron and brick building doesn't work. It's not precise enough. So it gives you a precise location. Don't tell me you were in the room. I know you were in the room. And the second one is that it's proximity detection. You're approaching me in less than a meter, and so you don't have to scan the code of this machine. We already know you're standing at the machine. It's saving a click. Is this the top priority in instruction management? No, it is not, but it is definitely something that can make it a little bit more lean, saving a click, saving a scan, and add to the performance. But it's not the first one I would put on the list. The second thing is, okay, we heard a lot about contextual information. You're doing a checklist or a procedure, check this, do that, and then at a certain moment in time, the guy needs to be informed on something. And we came up with a kind of quite generic solution, what we call an Internet of Things card. What it does is, it tells at that moment in time, the server, the cloud solution, tells the app, go to that URL with that secret key, with those information, who is doing what, which procedure, which case, which machine he's standing on, send that to that page, and then, depending on the situation and the client, that page can give him something back. And that can be anything. It can be the weather forecast for tomorrow, double check the isolation for a certain pipe. It can be a monitor that streams constantly temperature because he needs to take a closer look. It can be anything. And that is connecting the guy, the lady, whatever, the operator, to the Internet of Things during his instruction. Now we come to the glasses. I found it very difficult to make a statement about glasses, so we came down to a kind of a taxonomy to frame the mind, and we come up with 5 different types of glasses. And I think so far, everything I've seen out there for the last couple of years fits into this picture, still fits into this picture. Glass cameras, it's the GoPro in a glass. No more, no less. It just captures what your eyes are seeing. There is no display for a good reason, because your eyes need to be on the real world. If you're going down from a canyon with your bike and you like to have your friends enjoying the death road you're taking, you don't want a mail coming in. It would be the wrong timing to consult a mail when you're that far of an edge. So there is nothing than a camera. The second one is the smart rear mirror. The Google Glass is the perfect example. It is a little display, the Vuzix is another one, a little display hanging in the corner of your field of view. Why in the corner of your field of view? Because you want your eyes on the reality. So it's not augmented reality, it is focus on reality and then have a little information in the blink of an eye in the corner of your field of view. I call this informed reality. Then the third and the fourth category is different. Now we're talking most of the devices and certainly the binoculars. It's a very crowded space with the Moverio, the HoloLens, the ODG, all these devices. Your eyes are forced to look through an optical engine. And on that optical engine, there is an overlay of digital information on top of what your eyes are seeing. You can have it monocular and you can have it binocular, just a broader field of view. And then the last one is immersive eyewear, which is the Oculus Rift as an example. It's abducting you from reality, plunging you in a virtual world. Now, for instructions. What to use? We come up with this generic graph that tells you two things. On the horizontal axis, there is the enriching of your natural view, feet of the mind. On the vertical axis, there is the view on the world and the vigilance of reality. And it's communicating. At the extreme point there, you have the virtual reality. The feet of mind is to the maximum. But your view on the real world is 0. On the beginning of the horizontal axis, the GoPro in a glass, Pivot Head is a quite known brand, that has no display whatsoever. You're just looking at the real world. So the field of view on the real world, the vigilance is 100%. But the enrichment on top of what your eyes are seeing of the real world is 0. And so you go down from full eyes on the real world to 0 on the real world and fully indoctrinated by a virtual reality. If you're talking instructions, and this is a key message, if you're talking instructions, for education and training, virtual reality is perfect. Augmented reality might even be better, because then you can sit down, you can try it out without doing it. But when you're standing at the machine and you're drilling holes with the machine or bending metal sheets, you want your eyes on the machine. If not, you could lose easily a couple of fingers or a hand within a couple of seconds. So even from a safety perspective, the cognitive load must be minimal. Are you going to be maybe distracted with a very painful outcome? So there, in the, I would call it Pareto-wise, 20% of the complexity, but 80% of the use cases in industry is, I would call it in instructions, simply informed reality. Okay, let me look at the machine, but yes, if I have to know something like the rear view mirror in your car, it's there all the time. You use it, what, 20 seconds while driving for an hour? But you need it. Sometimes it's going to save your life. But if you look constantly in the rear view mirror, you're going to have plenty of accidents. That's the whole idea of the smart glasses. So yes, they're all useful for instructions, but some of them for training and education, and others for guiding you during the execution of your task. Last point is the integration. So there is a wearable platform connecting your glasses, your watch, your mobile phone, telling you what to do. And as I explained with the maintenance person, check me this temperature every hour, check me that pressure every day on a compressor, you are doing it on paper. Integration of paper is zero. So is there an integration problem? Well, is there an integration problem today? It's all on paper. So there you can directly communicate to the wearable device and tell him, okay, fine, do this now or do that now. But part of the, to come back to the maintenance guy, part of his work is also repair and maintain shutdowns, for example, machine revisions consuming spare parts. That part of his activity is managed by enterprise resource planning or enterprise plant maintenance modules, Maximos. And so there, the whole thing, the backbone of what he needs to do is managed by these ERP systems. Now, if he's walking with a mobile phone in his pocket or walking with a smart glass on his nose for this replacement of paper instructions, the natural question is, he's wearing the glass anyhow, can't we bring also the work order, the repair order, the shutdown planning, can't we bring that also on the glass? So there is a natural demand for integration with the backbone and to make sure that he exploits the wearable device to the maximum extent. Just as a summary, I'll take our own platform as an example. Our Proceedix platform that handles all of this, and I would say in a quite pragmatic way, it leverages cloud computing because that's the advantage of in the cloud. Yeah, you scale it easily. It has the Internet of Things connectivity. So yes, you can have the weather forecast when it's relevant. The mobile thing, I would say roughly, and certainly in Europe, 95% is still on mobile, if they have mobile, because most have paper. Then data analytics, it has been mentioned, a huge potential it's created to do statistics on top of everything that is registered now, because everything is logged. Some call it Big Brother, but yeah, where you're standing, when you started, when you stopped, we all know it. Then there is the wearable thing, one comment there. What works on a wearable works on a mobile. What works on a mobile does not work on a wearable because it's a different UX. What you see there in the little corner is not the same as what you have in your hand. So it's a different UX. And leveraging the mix of things, that's also an important message I want to give, is that it's a mix of things that brings a solution. It's not one glass, it's not one type of glass, it's not just beacons or another, it's the mix of things where you can combine a glass with a ring scanner, for example, or directly connected Bluetooth with a sensor, a measuring device. It's the mix of things that will bring a solution for the worker, and it's only the solution that is of interest to the worker. The technology is just a way to get there.